16. Which of the following ions has the smallest ionic radius? So that is the size across the atom from the outside electrons to the outside electrons on the other side. And you notice our choices here aren't random. They all are isoelectronic with neon. To convince yourself of that, look at oxygen. Oxygen's right here. If it has 2 minus, it gained 2 electrons to go from 8 to 9 to 10. And fluorine minus gained 1, so it's there. Magnesium plus 2 lost 1, and then lost 2 to become like neon. And aluminum plus 3, same thing. 1, 2, 3, and it's back to neon. So they all have the exact same electronic structure, which is to say, you notice they have 1 ring, 2 rings of electrons. So let's draw 2 like that. In the first ring, there's 1, 2 electrons. And in the second ring, of course, if we count 1, 2, 3, 4, 5, 6, 7, 8. So we can put those in there. So they all have the exact same. So you might think to yourself, well, 6, 7, 8, I missed one. They're going to have the exact same size, but they aren't, because they have the same shielding, same number of electrons and everything. It comes down to the nucleus. So which one has the most effective nuclear charge? Because remember, it will pull the electrons in and make it smaller. And so of our choices, you'll notice that oxygen has 8 electrons, or 8 protons in the nucleus. Fluorine has 9, and so on and so forth. So it looks like magnesium, aluminum is going to be the one that has the most number of protons. It has 13 positive protons, and so it will pull them in the most. And so D should be our correct answer. Number 17, which of the following is true of the halogens when comparing them to other elements in the same period? So let's start with atomic radii, because this first one is looking at atomic radii. And remember, at the same period, it's important to remember that a period is not a column. These are the halogens over here, but we are not comparing them in a column. A period is a row. So let's just pick chlorine. Chlorine is the halogen, and this is its row. So how does it compare with atomic radius? Well, they're saying they have larger atomic radii than other elements, and that is definitely not true, because you remember that as we go to the right here, we are gaining the number of protons in the nucleus. Notice 12 protons, 13, 14, and so on. Actually, chlorine has one of the highest number of protons, and so it will pull its electrons in. So I don't think that A is going to be the correct answer. So let's see what our next choice is. They have lower ionization energy. Well, doing chlorine again, remember ionization energy actually increases as you go up and to the right. Fluorine has very high ionization energy. So chlorine is going to have one of the highest ionization energies. For the same reason, it has so many protons in its nucleus, not only does it pull those valence electrons in, but since they're pulled in closer to the nucleus, they'll be bound more tightly, and it will be difficult to remove an electron. So I don't think that that's the correct answer either. That seems like it's not quite true. C, they have less peaks on a PES than the other elements within their period. So photoelectron spectra, you remember, let's start with sodium. Let's compare sodium to chlorine. Well, sodium's highest energy orbital is the 3s2. And so it will have peaks all the way up to that point. 1s2, 2s2, 2p6 is going to be really tall, then 3s2. So that's what sodium looks like. And chlorine is going to look exactly the same, except for its highest energy orbital is the 3p5. So it's going to have 1s2 just like sodium, 2s2 just like sodium, 2p6, 3s2, but then it has this 3p5 peak. So it actually has more peaks on the PES than the others do. So we can get rid of that. D, their electronegativity is higher than the other elements within their period. That is definitely true, because remember, if fluorine has the highest electronegativity, as in it pulls on electrons in a bond more than any others, then as you go right, electronegativity must increase. So D must be the correct answer. Number 18, in general, do metals or nonmetals have higher ionization energies? Well, let's start remembering the dividing line between metals and nonmetals. It divides right between boron and aluminum, and then it essentially does this stair step as it goes down. And on this side we have metals, and on this side we have nonmetals. And so then let's look in a period. Remember, once again, we're talking about a row here, so like a cross like this. And so I would say on this side, the metals are definitely going to have lower ionization energy than the non-metals. And since they want to know which is higher, I guess we're going to say the non-metals. So we can get rid of A, because metals are not higher, and C. And then we got to come up with the reason. Non-metals, because they are larger than the metals. No, I don't think so, because remember, francium's the biggest element, helium's the smallest, and so as you go this way, they're getting smaller. So I don't think that that's true. And then D, non-metals, because they are closer to having a complete energy level. Yeah, it's not the best argument, but it certainly works because the nonmetals only have to gain an electron or two. So I think D is going to be the correct answer, even if the explanation isn't great.